Building software without mapping the user's path is identical to framing a building without a blueprint. The structure might stand temporarily, but it won't support the people actually trying to use it. To build stable software, you have to map the user's path first. Flow first, screen second, code third. A user flow maps the exact step-by-step sequence a person navigates to move from an initial intention to a successful outcome. It tracks every decision, every piece of data entered, and every corresponding response from the system. Let's break this down using a standard process, creating a task in a project manager. Before charting the steps, you have to establish exactly who is taking the action and what they want to achieve. In this case, the user role is a developer, and their goal is to log work from an implementation plan so it can be tracked. This template shows the baseline structure. It defines the user role and user goal at the top. Just as important is the entry point. You must identify where the user is starting, like a dashboard, before their first step. Skipping the definition of the user, their goal, and their entry point leaves every subsequent design and back-end decision up to guesswork. Once the foundation is set, you map the main flow. This is the normal, successful path, where everything goes right, often referred to in development as the happy path. Looking at these numbered steps, the developer acts and the system reacts. But the flow must also account for hidden operations. Steps 7 through 9 are entirely system-driven. The system validates input, creates the task, and updates the interface. These invisible actions are mandatory. Relying exclusively on this ideal scenario creates a dangerous engineering bias. Assuming users will always have the correct data, a perfect internet connection, and zero hesitation results in fragile software. The main flow proves your feature works in theory. But real-world software must account for the friction of actual use, where users rarely act perfectly in practice. Alternate paths map valid choices diverging from the primary goal, like saving a draft or canceling a task. Error flows represent failure paths. User-driven errors, like missing titles, need one response. Systemic failures, like an API crashing, require completely different handling. If your back-end code cannot distinguish between a user voluntarily canceling an action and an API failing to execute it, you cannot write stable logic. A product's true resilience is determined by how gracefully it catches users when things go wrong and redirects them back to safety. Beyond errors, you must map invisible constraints. Developers need to know when a user tries to access a feature they aren't allowed to use. Explicitly stating that only authorized users can create tasks forces developers to build API checks, preventing security vulnerabilities. Let's test this logic. Imagine a user spends 10 minutes typing out a complex task description, clicks save, and their local Wi-Fi drops out at that exact second. How does the flow handle that? That is an error path triggered by a network issue. The map must explicitly instruct the system to cache their input locally to preserve unsaved data. Anticipating these hidden states builds a safety net, keeping the user moving forward with confidence. Once the document is complete, it acts as an architectural checklist. Look at these requirements. A single flow step immediately tells a backend engineer if they need to build a new API, alter a database schema, or set up async processing. It also dictates your quality assurance roadmap. The main happy path translates directly into your end-to-end testing script. Meanwhile, every mapped error and alternate path gives QA the exact conditions they need for rigorous API validation tests. If you use AI coding agents, a strict user flow provides the specific context needed to generate useful code. Instructing an agent to build only the defined front-end and back-end for this specific flow prevents it from hallucinating random features or writing bloated logic. Developers run into trouble when they ignore this sequence. Designing screens before mapping the logic, ignoring permission checks, or letting an AI invent unmapped error handling results in immediate technical debt. These maps serve as the source of truth that aligns design, data models, testing, and AI logic. This alignment ensures everything works as intended before a single line of code is ever deployed.